Now I would like to introduce the first speaker of the day today. We start the day's proceedings with a talk from down under, and our speaker is Dale Budd. A mechanical engineer, Dale Budd worked in both the public and private sectors as a manager and management consultant. He was chief of staff to the then Australian Prime Minister between 1975 and 1978, and for a period in 1981. In 1978, he became principal of his own consultancy in management and government relations. Today, he is director of Transport Heritage, New South Wales, that manages a variety of mostly rail heritage assets. This last is not his only rail connection. Between 2008 and 2010, he managed the Melbourne-Brisbane Inland Rail Alignment Study for the Australian Rail Track Corporation. Subsequently, he was a special advisor on implementation of the Melbourne-Brisbane project. From 2001 to 2007, he was the director of Australian Rail Track Corporation and served as vice chairman of the board from 2004. He had a particular involvement in the early development of the Advanced Train Management System. In 2004, he was a member of the UIC team, which provided a briefing on high-speed rail to the Indian Railways Board. He has also advised the Saudi Railway Organization. He was closely involved in the VFT and speed rail proposals for high-speed railways between Sydney, Canberra, and Melbourne. I would now like to hand over the stage to Dale. So all over to you, Dale.
Well, thank you very much, Mr. Singh. Can you now bring up my presentation and we will start. Thank you. Well, good.
So I'll just switch on the presentation mode. Yes, sir.
That looks good. Thank you very much. Thank you for that introduction. And good morning, everybody. So let's go on to the next slide, please. This is a list of the topics that I'll talk about. A brief introduction about Australia's railways. Then I'll talk about freight and then passenger, noting that apart from our commuter systems in cities, the main job for Australia's railways, the long distance lines, is very much freight. I'll talk a bit about heritage rail, which is an interesting area with some new developments. Then I'll talk about advances in technology, which are starting now and many more to come. And then I'd like to talk about how some things in Australia, some trends are similar to what's happening internationally, and how some of them differ. So next slide, please. First, a few facts about Australia and its railways. If you look at the map on the right, you'll see sections in different colours. The lines in blue are what we call narrow gauge, 1067 millimetres, was 3'6" in the old days. The red lines are standard gauge. The green lines in the southeast corner are 1600 millimetre gauge, used to be 5'3". It's worth noting, and there's more blue in the southwest corner as well, narrow gauge. And it's worth noting in the northwest of the country, a little patch of standard gauge lines, which are iron ore lines. I'll be talking about them. Australia is a very empty country. There's a lot of sparsely populated area in the centre of the country. So our total population is 26 million people. We have about 36,000 kilometres of railways, which, as you would know, is very much less than India. So we don't have a very dense network. As you can see on the slide, the commuter systems around major cities are run by the state governments, and this applies to railway operations which used to be and are still state-based. The interstate network, which is many of the long lines in red, are owned by the national government through the Australian Rail Track Corporation, or ARTC. ARTC doesn't run trains. They are run by private operators who pay access fees. And next slide, please. The heavy haul iron railways in the northwest of Western Australia are built and owned and operated by the mining companies, which are, of course, private companies. I've mentioned the three main gauges that we have, a legacy of terrible decisions made 150 or more years ago. In a part, as well as those three main gauges, there is quite a lot of sugarcane haul on 610 millimetre gauge, 2 foot in the old style. We do have standard gauge tracks linking all of the mainland capital city, but we don't have an ongoing program in Australia of gauge standardisation. So let's move on to the next slide. Talking first about freight, the biggest current rail project in Australia, now under construction, is a line from Melbourne to Brisbane, 1,700 kilometres in length, standard gauge, and it's a mix of existing lines. You can see the figures there, some upgraded from branch line status up to mainline standard, and about 500 kilometres of new construction. The cost is around 14 billion Australian dollars, which is, by my calculation, about a bit more than 75,000 crore rupees. The trains will initially be, and we are talking about freight trains almost entirely on this line, trains will be 1,800 metres long, with provision for a later increase to 3,600 metres. They'll carry double stack containers, and the transit time from Melbourne to Brisbane will be reduced from 30 hours to 24, with much higher reliability. Not only will the route be shorter, but it will not go through Sydney, the biggest city in Australia on the east coast, where freight trains are delayed by commuter trains. Next slide, please. Continuing on the Inland Rail project, in the sections in Queensland, the northern state, it'll be dual gauge, as you see in the picture. This will enhance the Queensland narrow gauge network. The biggest engineering feature on the line is a long tunnel, 6.4 kilometres long, on a fairly steep grade of 1.67%. This project is under construction and scheduled to be finished in 2027. I've had a long involvement in this project, and the experience has been that the approvals process, environmental approvals in particular, across 3 states and a national government, 4 governments to deal with, are very complex and very time consuming. Next slide. The other most perhaps best known new railway in Australia at the moment is a line from a new coal mine known as the Carmichael mine, and previously known as by the name of Adani, a mine in central Queensland. The original plan was to build a brand new standard gauge line from the mine all the way to the port at Abbott Point, but eventually the company decided to reduce costs, and so it's going to be, or it is, a narrow gauge 1067 millimetre line from the mine for 189 kilometres, linking to the existing railway. The first trains ran in only a couple of months ago in January, and this project, the mine and the railway, are Indian owned, and the coal will be exported to India. Next slide, please. I see a question asking about electrification. The commuter railways in the main cities, the state capital cities, are electrified, and there is some regional electrification around Sydney for distances up to about 160 kilometres, but none of the long distance, there is some long distance electrification in Queensland. I have to remember as I go. Some of the coal mining railways in Queensland are electrified. There's not much in the rest of the country.
If I can come in, Dale, we'll take all the questions at the end.
Okay.
So I suggest you go ahead with your presentation, and at the end, we'll take all the questions.
I'll do that. Okay. Next slide, please. I've mentioned that freight is the big business for long distance lines in Australia. The rail's share of the freight business from Sydney and Melbourne, the two main eastern cities across to Perth, is a good, strong position, and rail's share of the land freight is around 80%. For the greater part of the route, as you can see there, we can do double stacking, and that will be a feature of the Melbourne to Brisbane railway as well. There is quite a deal of competition from ships between Sydney and Melbourne and Perth. We're talking about cities that are all on the coast with ports, and so there is competition from ships for freight, which is not time sensitive. Next, please. In addition to intermodal freight, coal and grain, mostly wheat, other grains, is big business in quite a few of the states. Newcastle in New South Wales is the world's largest coal export port, with the figures you see there, a capacity of 200 million tonnes per annum. I think the peak figure was what's shown there, 158 million tonnes of coal were exported in 2020. In Western Australia, and these are the lines that you can see on the map, which I mentioned earlier, we are in the northwest of West Australia. The iron ore railways in Western Australia are world leaders in the heavy haul business. As I've mentioned, they're privately owned. Their total route is about 3,000 kilometres, and they run, as you see there, very long, very heavy trains with probably distributed power with perhaps anything from 6 to 9 locomotives per train spaced out along the train. And I'll talk a little later about a very interesting advance in technology for one of the iron ore lines. Next, please. It's worth mentioning the sugarcane operations in Queensland. We're talking about narrow gauge tracks, not unfamiliar in India. We're right down at 610 millimetres, but there's something like 4,000 kilometres of route. A short new line is under construction and nearly completed. Quite a fleet of locomotives. Some runs up to, some very short and some up to 120 kilometres. And the trains are up to 2,000 tonnes a kilometre long. And the total haulage each year is something like 36 million tonnes of cane. A very sort of interesting, not so small operation. So next, please. Coming to passenger services, I mean, the main passenger role in Australia's railways is commuters around the capital cities, and Brisbane, Sydney, Melbourne, Adelaide and Perth all have electrified commuter networks. In Sydney, we now have an automated metro with quite considerable extensions under construction, and they're planned for Melbourne. Sydney's metro trains, incidentally, were built in India by Alstom in Andhra Pradesh. And there are, in addition to the metros, there are conventional commuter lines under construction in Brisbane, Melbourne and Perth. And next, please. And in Brisbane, we have a significant project known as Cross River Rail. On the map, the new Cross River Rail line is in blue. There's already a substantial network, but it's overloaded, overcrowded, and so a new underground, mostly underground Cross River Rail line is being built, and there are new trains being delivered. That train you see there is painted in an Indigenous artistic scheme, which is something of a novelty. Not all the trains are painted like that, but it's an attractive Indigenous design. And next, please. In Melbourne, on that map, in the centre of the map, you can see a fairly short blue section. That's an underground railway, which will leave some extreme congestion in that area. And then there is a large suburban rail loop planned. That's the black lines and the green lines to the east. That will be an automated metro, still some years off, only in the planning stage so far. And for the conventional commuter lines, there is a large fleet of new trains, and that's what you see there, currently being delivered for the existing network. One more slide, or the next slide, please. In Perth, I don't have a map, but there is a lot happening in Perth, in Western Australia. Several new lines, new projects, and a fleet of new trains. That's an artist's impression on the right. Railways, from a slow start in the past, have become electrified. Suburban railways have become a very large part of Perth's transport. And can we go to the next slide, please? Coming to regional or fairly long distance services, there is some replacement of rolling stock, but a few new developments. The two trains you see there, the one on the left is a train in Victoria, which runs out of Melbourne. This fleet has been very successful. They started off with 2-carriage trains, as you can see there, expanded all of those sets to 3 cars, and now they run 2 3-car sets couple. Many trains are 6 cars. On the right, there is a new regional train in New South Wales running out of Sydney. All of New South Wales regional, all the suburban and regional trains are double deck and electrified, as you can see there. The Victorian train on the left is diesel. In terms of long distance trains, we have trains running between Sydney and Adelaide and Perth, and also Adelaide up to Darwin on the north-south route. These are resorts on wheels. They run only fairly infrequently, 1 or 2 times per week. They're very luxurious, very expensive. They are mobile hotels or mobile resorts, not catering for people who just want to travel from one point to another. If you do that in Australia, you mostly fly on the long distances. And those hotel type trains are keeping on going with rolling stock, which is now 50 years old, and it just keeps getting refurbished. I don't know what the prospects are for any replacement, not talked about at the present time. Let's go to the next slide, please. Light rail or trams is quite an interesting story in Australia. Melbourne has the world's largest tram network. That's a diagram which is not to scale on the right. 250 route kilometres, and you see the figures there, more than 480 trams, and new developments coming. Absolutely important part of Melbourne's transport system. And next slide, please. In Sydney, historically, Sydney once had a very large system shut down in the 1950s. Trams came back, and now we have a small system running out of the city. The two pictures on the right are in Sydney, and there's a line in the suburbs from Carlingford to Parramatta under construction. In Canberra, our national capital, the first light rail or tram line was opened in 2019, about to be extended. Stage 2 is coming soon. That's Canberra on the bottom left. Next, please. Heritage Rail, I think, is quite an interesting story in Australia. It's not only the past, but it is the future, if you like. And as I've put there, I think Heritage Rail is thriving, and some interesting and important steam locomotives have come back into service. The engine you see there in both pictures is the largest operating locomotive in the Southern Hemisphere, 260 tonnes, built in Britain in the 1950s, and only fairly recently restored to operation. Next, please. This is 3801, which is the most widely travelled and best known steam locomotive in Australia, probably also the fastest. It was built in 1943, and it's visited all of the mainland state capitals, but hasn't got up to Darwin yet. Maybe that'll happen. Its nominal maximum speed is 115 kilometres an hour, but these locomotives, the 38 class, have been up to 140 kilometres an hour. They were a very successful type. It's worth saying that the railway managers are very well disposed towards locomotives such as this one, perhaps in particular, because of the publicity they bring. This engine is a beautiful piece of machinery, and ministers and various important people, they like to be photographed with it, and they like to travel on it. So it's interesting that there is a lot of support for this sort of heritage operation and for the overhaul of some of the locomotives. Next, please. This engine is R766, a Victorian locomotive, which has been converted from broad gauge, 1600 millimetres, to standard gauge. This is the first conversion, a gauge conversion of a large locomotive in Australia. This R class were built in the 1950s, and they were designed for gauge conversion, for conversion to standard gauge, but they were replaced by diesels well before there was any prospect of that conversion happening. However, in the past, it was a long project, 10 years. This one locomotive has been converted to run on standard gauge, and it's just about to start in regular heritage service. Next, please. We have some heritage electric trains in Melbourne and Sydney. These trains are Melbourne on the left and Sydney on the right. We're talking about 1920s technology, a little bit earlier in the case of Melbourne, more like 1918 or so. And these trains run on 1500 volts DC, as the current commuter networks in Sydney and Melbourne run on 1500 volts DC. In Brisbane and Adelaide and Perth, we're at 25 kV AC. Next, please. It's worth also mentioning heritage trams or light rail. Several cities have operating tram museums, and in Melbourne, the government runs heritage trams on Melbourne's City Circle service. So that lower left picture is a very new modern tram or light rail vehicle with one of the City Circle heritage trams alongside, dating from probably about 1950 or so about 70 years old. The picture on the top right is a very old tram in the Sydney Museum, dating from the 1890s, and on the left a quite new light rail vehicle that for some odd reason was prematurely replaced. And there's a tram about 110 years old at the bottom right, a classic old tram which currently runs in Ballarat, one of Victoria's regional cities, on a museum line there. And now to move on to the next slide, please. There's a few things to talk about in the area of technology, and this one I think is the most significant technological development in Australia's railways currently. Rio Tinto, the very large mining company, automated the operation of its iron ore railway in Western Australia, now coming up to 3 years ago. They call it Auto Haul, and it is the first fully automated heavy haul railway in the world. These trains run without drivers or any other crew, and their operation is supervised from a control room about 2,000 kilometres away. The reason they did it was that this system eliminates 3 stops on the journey from the mine to the port, 3 stops to change drivers, and that saves more than an hour on each journey, because slowing down one of these 30,000 trains and stopping it and then restarting it takes a lot of time, as you would know. On the other side of the country, Sydney is installing the European train control system on the commuter network. Construction on one line, which is a short line, a good starting point, has begun, and that system will start operation next year. And next one, please. Back again on the iron ore railways in Western Australia, this is another very interesting development. 4 of the different companies up there are buying initially a small number of battery electric locomotives for delivery next year. They come from the USA. All of these, I should mention that all of those iron ore railways run to American standards or better or heavier, and they buy their locomotives straight from the USA. They are off-the-shelf American models, if you like. And these battery electric locomotives are also coming from America. They will be charged at either end of the line. The batteries will be charged up, and they'll also generate energy while they're in transit. I mean, the system is helped by the fact that the run from the mines down to the different ports is more or less entirely downhill from the mines. Are up, not in steep mountains, but they are elevated, and so the run downhill is helpful in generating power and storing it in batteries. And the railway companies are very optimistic, or the mining companies as they are very optimistic that they'll be able to expand the use of these battery electric locomotives and even maybe replace diesels altogether. Next slide, please. The ARTC, the Rail Track Corporation, which I mentioned owns the interstate network, is installing a system called ATMS, or Advanced Train Management System. And this will incorporate, as you see there, real-time monitoring of trains. They will know exactly where trains are. We're talking about lines, many of them out in desert or near desert countries. Speed. This will enforce speed limits and end of authority limits, if you like, stopping at red signals. The system will have minimal trackside infrastructure, and the communication will be by cab displays. Next slide, please. This diagram shows the reduction in trackside infrastructure. The top line shows a single track line, 2 passing loops, and you can see a myriad of signals and different wayside enclosures, all of them needing maintenance out in a pretty inhospitable and sparsely populated part of the world. And the bottom diagram shows the simplification which is being achieved by ATMS. And also at the bottom of the slide there, you see it's mentioned electronically defined train separation. That means that trains can run more closely together rather than having to work on fixed physical blocks. And if trains run more closely together, you can increase line capacity. So it has both safety benefits and an increase in capacity. Next slide, please. The diagram at right is the driver's display that he or she will see in the driver's cab. Just looking at that diagram up at the top left, this train is running at 75 kilometres an hour within its speed limit of 100. Over on the top right, it is at the 81.5 kilometre post. And if you look at the main part of the diagram, you can see how the speed limit is going to progressively fall over the next 7 kilometres or so until this train has to stop at 88.49 kilometres. One of the beauties of this system is that it incorporates enforcement, and not only is it a case of stopping the train if it overshoots the end of authority, the red light if you like, but the system can tell if the train is slowing down sufficiently to stop at the right point. And it detects if the train is not slowing down. And if it's not, the driver will get a warning. And if that warning is not attended to, then emergency brakes will come on. And the system can be applied to not just to end of authority points like red signals, but it can set speed limits on curves, and it can impose temporary speed restrictions when track work is being undertaken. So it's and that can be done just electronically by reprogramming the computer. So it's a very versatile, very powerful system. It's already in operation on a short line in South Australia between Port Augusta and Whyalla. This was a suitable line to be the initial installation. It's currently being installed on the western half of the transcontinental line. It will be included on the Melbourne to Brisbane inland line, which I mentioned as being under construction. It's one of its merits, especially in the area that we're talking about in the middle of Australia. It's lower cost than having balizers. I'm sure you know that term, beacons or transponders between the rails or track circuits. With minimal trackside equipment, the maintenance cost is greatly reduced. I think this system would be a good one for India on some of the longer lines. Next slide, please. I'd like to talk about now about similarities and differences between Australia and what's happening elsewhere. A feature of our long distance rail transport, and we're talking freight, of course, is intense competition from road. And trucks have got bigger and longer and heavier. Instead of what was considered a conventional semi-trailer, we now have B doubles. That's what's on the bottom left, B triples, which is the equipment on the top right, and road trains, which is the bottom right, sort of 4 units pulled by a prime mover. And of course, each of those developments is strong competition for rail. And the road industry has generally strong government support and a great deal of government funding. So the rail industry collectively, I think, has quite a fight to keep up with the advances and the funding, the road improvements that are going on in the road industry. And next slide, please. We're getting close to the end. The final slide really is more about the sort of similarities and differences. I would describe ATMS, which I was talking about a moment ago, as it's in line with world trend towards positive train control, which is the enforcement of compliance with signal indications, so that drivers won't, through an error or distraction or an instruction not properly understood, they won't go through a red signal with potentially catastrophic consequences. So that trend, that system is a particular one, but that's a world trend towards positive train control. To enforcement is the word that matters. And then I would say that Australia is a leader in heavy haul rail technology, and there are many other countries also with important heavy haul technology. But one thing we don't have in Australia is any sign of interest by government or investors in high-speed rail, by which I mean 300 plus kilometres per hour, and very little interest in even speeds of 200 kilometres per hour. There have been a number of attempts in Australia to make a start on high-speed rail, but they've fallen flat, really through government disinterest and any prospect of investors picking up the baton to run high-speed rail seems to be very remote indeed. And of course, as you know, that's I think a very bad contrast to India, where you have extensive plans for high-speed rail and the Mumbai-Ahmedabad project getting underway. So that's something where India is, in fact, India is very active. And of course, there are so many countries around the world with high-speed rail, and Australia is out of step, I would say. So we'll go to the next slide, which is my invitation to take questions. Thank you, everybody, for listening.
Thank you very much, Gail. It was a pleasure hearing about Australia. This is one area that normally we know very little about. Anyway, we have a number of questions. There was one question from Mr. Anand, which you have already answered, which was, any lines electrified?
Any electric lines? Yes. Well, around commuter lines around the cities, and in Queensland, some of the coal lines are electrified. But I don't see much prospect of major extensions of electrification.
Mr. Anand has also asked another question, which is, are all locomotives required for the Melbourne-Brisbane line procured, or are they still to be ordered?
No, still to be ordered. And you might remember I said at the beginning that the Rail Track Corporation, ARTC, it owns the network, but it doesn't run trains itself. So ARTC is building the Melbourne to Brisbane inland line, but decisions on what trains will be run and companies buying new locomotives and new wagons will be made by them. And those decisions haven't been made yet. We are still about 5 years away from the start of operations, and it'll be up to the various operating companies to make those decisions to buy new locomotives and new rolling stock.
A supplementary question, does Australia manufacture its own locomotives, or do you import them?
We have made some locomotives, but the trend is to importation. Some companies are still buying, we're talking freight, buying locomotives from Australia. Others are buying them from China. And the iron ore railways, as I mentioned, are buying them from the USA.
Okay. What about other rolling stocks, the freight cars and so on? Do you manufacture them, or do you import these also?
The story is of an increasing move to importation, and India is sharing in that by supplying metro trains to Sydney. Melbourne has made a stand saying they want their trains and their trams manufactured in Australia. Even there, the likely arrangement is that the body shell will be manufactured typically in China and imported, but then the electrical equipment will be fitted in Australia. And even some of that is imported from China or somewhere else. Regrettably, I think the proportion of local Australian manufacturer is tending to decline. It's a matter of economics. They can buy them more cheaply from overseas.
Mr. Raina has a point. He says, from what I know, a battery locomotive will be embedded in a diesel loco consist. That will save on braking energy. He does not think that the battery locos will replace all diesels, particularly on upgrades, even if they are zero payload.
Yes, it's a good question. I think what we are going to see initially, and the iron ore companies have said this, that they're buying a small number of the battery electric locomotives, if you like, to test them out. And they say that of a set of 3 locomotives, they will replace one of them by a battery electric locomotive. So the combination will be 2 diesels and 1 battery electric. And that will really be, if you like, a large battery on wheels. And so when it's charged up, it will add to the power of the diesel locomotives. Now, the companies have gone on to suggest that perhaps they can replace diesels altogether. My view is that may be much, much harder to achieve. We'll see. They're going to take it step by step and see what happens.
Mr. Matthias Meyer, he has a question. He says, I understood AMTS is based on GPS. Is this reliable and safe enough?
I believe the short answer is yes. GPS is very widely used in aircraft navigation and provides very precise location, down to meter accuracy. And I don't see why it should not have the reliability. And certainly on this system that's being developed, ATMS, ARTC has gone through very lengthy trials and testing to establish the accuracy, the precise accuracy of the train location.
Mr. Apul Bahadur has a question. He says, in Australia, do the American design industrial lines drive on the right track?
No, Australia inherited its first railways from Britain, and we run everywhere. When there is double track, we run on the left, as we do on our roads, drive on the roads. Of course, A great majority of our long distance railways are single track, so it's not an issue that arrives.
Another question by him is that in the two metro cities, will the 1.5 kV DC ever be converted to 25 kV AC?
There's never been talk in Australia of converting. We have the cities of Sydney and Melbourne have 1.5 kV DC, and Sydney has a regional network extending up to about 160 kilometres away on two lines. Melbourne is all a more condensed suburban network. But I've never heard anybody suggest that it would be, India has done it, I know, but it's never been suggested in Australia as a prospect for conversion. And I think it is a pity that the more recent electrifications, although there haven't been any for many years, you could have a change of voltage en route. You can have, everybody knows, you can have dual system locomotives and you can change, but I guess we have been conservative and just stuck to 1500 volts DC.
There are a few more comments in the chat regarding the very good presentation that you made and how comprehensively you covered everything about the Australian Railways. I think we couldn't have had a better bird's eye view of the Australian Railways than what you have given today.
Thank you.
So thank you very much, Mr. Dale.
Dale, I have a small question to ask Mr. Ward.
Okay.
I'd been to Australia many times, and I had been a great fan of the Hunter Valley Coal Roads out of Newcastle. And
Yes.
I've seen the operations many times. And so I was just seeing the map from the Brisbane-Melbourne track. So does the Hunter Valley Coal Road routes go and hit on that track, or can the trains from Hunter Valley Coal Road get into that track?
Basically, no, they're not connected. The Melbourne to Brisbane line at one point, and I had a slide on a map on one of the early slides. At one point, it goes through Narrabri, which is just about the upper limit of the Hunter Valley, or very close to the Hunter Valley coal operations. But I don't think it shares any track actually with the Hunter Valley coal. And I mean, those Hunter Valley coal lines are so busy that you would not want to try to put a sort of an interstate operation on top of them. By the way, I should mention that I don't know whether this is going to happen, but there has been talk of putting ATMS, the train control system, onto the Hunter Valley lines. I'm not sure what the current plan is for that.
Okay. Thank you very much. Thank you very much.
Another question has come in, Dale, which says, what benefits have been achieved by ATO on Rio Tinto freight line?
I'm sorry, I missed that question. By benefits by what?
This is by Mr. Chandrika Prasad. He asks, what benefits have been achieved by ATO on Rio Tinto freight line?
Automatic
by
train
ATM.
operation. Yeah.
The ATMS, it's really too early to say. It is operating on one short line down to the steelworks at Whyalla, from Port Augusta to Whyalla, and that is a good line for a prototype, but it's not busy enough to really gain the benefits of ATMS. It's currently being installed between Tarcoola in the middle of the transcontinental line and Kalgoorlie. And when that's up and running, I mean, it has a safety benefit primarily, that a train driver, if he or perhaps she, if they become disoriented and not sure of their location and they don't stop where they should, you can obviously have an accident, a collision or a derailment. ATMS will stop that sort of inadvertent error by a driver. And then when the line is busy, and the transcontinental line is getting busier, when the line is busy, there will be a capacity increase by the fact that trains can run close together, can be fleeted, rather than waiting a long while for a train to get it to a distant crossing loop 50 kilometres away. Trains can follow each other, and the system will know exactly where they are and will protect them. I think the benefits are to come. They haven't been actually put into effect as yet.
Well, thank you very much, Dale. It was an excellent presentation. There are a number of comments by a number of persons about how good the presentation was.
Well, that's very kind of you. Very kind of you. Yes.
Thank you on behalf of the Rail Enthusiast Society and from all of us in India. Thank you once again.
Thank you, everybody. Yep.
Okay, over to you, Manoj.